Hello everybody, it's Mrs. Pound, and this is the last section for Chapter 28 on color, and we're only covering one section today. And that section has objectives are to explain what the lines in a line spectrum represent and how such a spectrum can be used to identify the presence of an element. So our topic today is the atomic color code, atomic spectra, and we covered this if you had me for chemistry already. We have covered this and we have done something similar, but this is always a popular topic, so we'll do another lab in it as well. So this is a spectroscope that we will be using in lab. It's an instrument used to separate the color from a hot gas or other light source into its constituent frequencies. And here is what we will look through. There's an eye hole over here, and this is what you would see through this spectroscope. We will be looking at line spectra. This is a pattern of distinct lines of color corresponding to particular wavelengths that are seen in a spectroscope when a hot gas is viewed. And so here would be a continuous spectrum that you see if you look at white light. Here is an absorption spectrum where what the gas is absorbing is shown, and this is an emission spectrum. We will be looking at the emission spectrum. When an element of an when a sample of an element is heated until it glows, the colors it gives off are, so this is what we do when we stick the sample into the Bunsen burner, and this is also what happens when we look at fireworks. The composite of a variety of different frequencies of light. So we see one color, but what you really have is you have what is seen down here. You have a couple of different lines, but due to color addition and subtraction and all of that, you see one color. Two different elements cannot have identical line spectra because each element has a distinct arrangement of electrons. The electrons emit distinct frequencies of light when they change from one energy state to another. This is like a fingerprint for each element. So if we look at hydrogen, hydrogen has, it looks like 4 lines. Neon has many more, and beryllium even more. The number of lines depends upon the number of electrons, and there are different energy states the electrons can be in. Remember, we talked about energy levels, we talked about orbitals. So electrons jump up to another energy level when heat is added, and then they give off light when they fall back down to their lowest energy state. And they can jump up to different levels, and then when they fall down, they give off different frequencies of light. And so that's what produces those lines. So our objective today was to explain what the lines in a line spectrum represent and how such a spectrum can be used to identify the presence of an element. So try to get 5 questions, and this is it. You can start studying for your test.